director and a driven element or a receiving element and a reflector. And they have a pattern exactly like this. If I was holding the paper over his antenna, this. My name's Bruce, N6THN, and I noticed there's several antennas in here that I didn't bring, so can you raise your hand if you brought an antenna tonight?
Sorry?
What?
Can you raise your hand if you brought an antenna tonight?
I did.
I know you did. Okay, do you mind if I call on each of the four of you to explain your antennas too? Because we're all here to learn from each other. So.
Well, I brought your antenna, so.
Okay.
That you built.
There's other ones here. There's a lot of them here. I actually started DFing as part of necessity. I built this loop to walk around my house with this 100-foot of wire to find out a lousy source of interference that was bothering my HF station. So this one is around the VHF band. And it's just clipped here and here to a 259 jack, and you unclip it here and here, and then you can change the band. So this is VHF, and this one is UHF. It's just a single turn of 12 gauge wire with clips. So in case my noise was coming in from a UHF source, I tuned this one to be more in the 440, 500 meg. This one's down between 300 and 100 meg. In fact, it tunes in KUIC perfectly. You know, beautiful job. And then this one is 5 turns of the same 12 gauge wire, and this one is for HF, around 1 or 2, 3 meg, 6, 7 meg. So I was going to go around the house sniffing the VCR, the clock radio, the microwave, you know, do this type of thing. Are you noisy? You know, are you noisy? Or, you know, something else noisy? You know, listen to it. And so that's why I built these. And then you guys said, how about have a fox and hound?
Fox hunt.
I go, oh, great, because I've already got 3 antennas made. But I didn't make them for the contest. I just made them to find out my HF problem. So what this is Bob, can you hold this? He's my assistant. This antenna comes over here.
Small brain radio guy.
He's not a small. That antenna comes to this RF detector probe, which I'm going to talk about up there in my hand. This RF detector probe. And we've simply got the output of the probe hooked to this meter. So this is one way. Let's see if we get a signal. Can y'all see the meter?
Yeah. Yeah. Oh, look at that.
So I've got my radio on 3 watts right now.
So this is just a voltmeter right here?
Yeah, it's just a 3-volt analog meter. So can you see it when I punch the button? 3, 2, 1, now.
Oh yeah.
3, 2, 1, now. And Bob's the antenna. So I haven't tried this. This room might have reflection. I'm gonna hold it down. Hold it broadside to me, because that's the buzzer signal. And then go ahead, Bob. Oh, it's on too high. Okay, it's too sensitive. I'll turn it up.
Very sensitive.
Okay, now it's there. Very slowly turn it broadside. Yeah, we're getting too much reflection in here. See it going up and down? It's going up and down slightly.
Yeah.
But at home and out in the field,
Analog simulator around.
okay.
Go ahead, Brian.
Go ahead, Bob.
Can you change?
No, you're too far away now.
Turn it. Can you turn it?
There you go. I don't know if everybody can see this.
Look a little.
But anyhow, when you come upon something that's noisy with this, you can stop transmitting. this going into the detector or this going into your scanner or ham radio, then you can hear your interference source. So I'll just have him start the slides and show you the process to build an RF detector. And this is also good enough to troubleshoot ICs in circuit boards. For instance, you're probing a radio. Do you have juice? Do you have juice? Do you have juice? It goes up to a gigahertz. So I'll leave it here and look at it after the show. So that probe is just a 100 picofarad cap in the front end, that yellow thing. This crystal diode right there to ground. Another crystal diode passing, that's the actual detector to detect AM, right there. Another 100 picofarad to ground, a 1 meg resistor to load it, and the output goes to a B and C plug to your scope. So it's just RF coming in, blocking diode, detector diode, a little bit of a storage cap, and then AC or DC audio outside. So go to the next picture.
Are those loops on the far right?
Yeah, those are just soldering loops
Oh, okay.
for the low frequency.
Okay.
So go to the next one. And that's the bottom. I mean, this is like my ground bus, and this touches a shield. It's just the ground bus on the edge of the circuit. Go ahead. Okay, inside of the PVC pipe is shielded. This is a 4-inch long pipe. So inside of it, all the way around, is this brass. I bought this brass and did a 1-turn wrap inside this pipe, put in the circuit board and the 2 end caps. So I started curling up the brass to make a shield so that my hand wouldn't act as the antenna. You know, I didn't want my hand to attenuate or add to the signal. So I shielded it with this brass, and it's touching this ground plane when I slide the whole thing into this tube. Go ahead. So this is the probe. This goes to the front end diode. The rectified DC goes to the output. And I got the brass started to go into the tube. Okay, now the brass is halfway in and the circuit board's halfway in, and the wires aren't soldered yet. Keep going. That's the internal probe for this brass sharpened screw and the ground.
Did you fabricate that probe, or is that something that you can buy, or?
Yes, I
Oh,
fabricated
screw.
a
I see.
screw
Gotcha, all right. Yeah, I couldn't see.
and a wig nut for the ground lead. Okay, and that's the B and C end, that's this end. That's the DC output. And it's just coming together. I'm just laying it out, how I'm gonna do it. And now I try to get these leads as short as possible to this probe.
Yeah.
You're looking at it down this way. So I tried to make these suckers like 3/4 of an inch or less.
So did you solder it while it was in that cap? So you were down in there with the soldering?
Yep, I got it in there. And it's pretty much completed. And then, and then this is with the B and C cable to hook up to your oscilloscope. So that's for doing circuit board testing. You just grab this thing and do your probing, transistor 1, transistor 2. You know, at 440 or 500 meg, 800 meg, you can't see the signal on most cheap scopes.
Yeah.
So you need a probe to detect the signal. And I think that's the last picture. So that's a probe project to work with either these loop antennas or testing circuits. So now I'm going to go into, if we were DFing ham radio, I'd use this and hook the other end to our HTs or spectrum analyzer.
So what would you see on the S meter? You're looking for the S meter?
Yep. Let me explain. When the signal is, when the transmitter's over there and the wall of signals are coming, and they're basically 20 inches apart, you know, for quarter wave, so it goes. slam, when it hits this, it induces a voltage in the whole thing and it comes down here. But when it goes like this is called broadside.
No.
And when it goes endways, when the signal's going, and it hits this and it cancels here, you don't get anything. But the problem is when you're DFing, like if you're my transmitter, and I go like this, oh, it's really strong. So it could be that way, or it could be that way.
Right.
So then I go like this, and I go, oh, it's really weak. And that's where I light up my compass. I go, okay, it's either that way or that way. So I thought, uh-oh, this has a problem. Now I have to move a block or two, like over here, and then do the same thing. And if he still hasn't moved, I go, oh, it's really strong, but my compass angle just changed. And the compass angle for out that way didn't make sense anymore, see? Because it went,
Wide.
yeah, it got out of the picture. But I have two lines that match now. I have a line that still goes his direction, and then when I'm over here, I have another line that goes his direction, and I have two erroneous lines that don't go right. You know, one of them goes like that, it's diverging, the other one's diverging that way, so I know the converging lines is where I gotta walk around and find. So that's an example of how to use a loop. It's not the best antenna, but it's an antenna. So now I'm gonna go into, really quickly, Yagis. Can you hold up your Yagi, Bob? And I'm gonna have you talk about it later.
Oh, the tape measure Yagi.
The Yagi has a director and a driven element or a receiving element and a reflector. And they have a pattern exactly like this. If I was holding the paper over his antenna, this big lobe is where all the signal is. Off the tips, into the middle is weak signal. And off the back, you still get some signal there, but the most of the signal, like if you're pointing it around this way, like this, most of the signal is going to be coming in on the front.
This one actually got a notch in the back.
Oh, it's got a notch in the back, that's even better. So with Bob's antenna, this is usually the polar chart, they call it polar. And this is the degrees that the antenna has kind of a dead zone where it's strong everywhere you point it, right here. And then off here it's really weak, and off here it's really weak. And down here it's still some signal, but it's pretty weak. So with Bob's antenna, if we were walking it around, it would find you pretty easy compared to the loop. But the loop has a really deep null in it when you hook it up to a sensitive receiver too. In fact, World War II bombers used loops to direction find if they were on course to like Hawaii or whoever. You know, they'd get the signal broadside, then they get the signal null, and then they'd head that direction where the null was. Because the broadside signal's like from over there to over there. They were getting it like this far, and they go, the island could be anywhere over there. But as soon as they turn it towards the null, they go, oh, that's where it was. It's right there. So that's a Yagi, and I'm going to have Bob talk all about his antenna in a few minutes, but that's the basic pattern. By the way, this probe took me a lot of experimenting. All these little devices here are diodes that I went through my junk drawer. These are all crystal diodes. And I tested each diode with a signal generator to see which one would perform good. Like these little glass ones went over a gigahertz, these little glass ones. But these plastic ones only went to 220 meg, and then they died. So they're like power supply diodes, they're no good. But these little glass ones really picked up, and so that's what I used in this, is the glass ones. So we've talked.
I made a one for 1286, and the glass ones work beautifully there.
For 1286 megahertz? Yeah. Well, that's what I'm using too, is the glass one. I tested mine up to 1040, 1040 or 1.04 gigahertz, and this probe was still working. And that's as high as my generator can go.
Funny, Bruce has diodes in his junk drawer. I've got like rubber bands and pens that don't work. Yeah.
So we've touched loops. We've touched DFing around the house for noisy power supplies that knocking out your radio so you can't hear
Did you find the problem?
Just what I'm saying.
The problem went away by itself. It was like a neighbor or something.
You scared it. Fucking neighbors over there.
There he is, Power poles that are too noisy, you know, you can go, hey, no, that's the noisy pole. No, that one's not noisy. It's that one down the street. So anyhow, loops are
Eating on the job.
old fashioned, but they work great.
Cool.
Now I'm going to talk about an antenna that has a really strange pattern. They call it a heart-shaped pattern or cardioid. This is the proper way to look at it. And that is this antenna. And that bugger is basically a quarter wave dipole. So this is 20 inches or 19. This is really 19. So it's a dipole. And over here it's another dipole, identical. And in the middle, I did the magic. And this distance between here and here is a quarter wave. How come I'm using so many quarter waves here? And this is a quarter wave. So, and that one's a quarter wave, and this is a quarter. There's 4 quarter waves on this stick in this thing. So this one is going to end up with a cardioid pattern, which is going to have high gain all the way around here, but a 0 notch right in the middle, better than my loop. So I'll show you how I got that. So I ran a quarter wave length of coax here. There's that quarter wave again of coax. And over here, I wanted to make a null or a notch, so you have to cancel out the signal. So I go, how do you cancel out the signal? Well, with a half wave. Okay, I'll just do this. This piece of coax is twice as long as this one, and they actually do end up at the same point where I soldered them. So this is a half wave delay line. And this is a quarter wave. And I just tied them together, down to the radio. Like that. So what happens is your big old wave comes floating along, and we're looking for cancellation. So when this negative wave hits this antenna, it makes a, let's just call it a minus voltage on that point. And when this wave floats on through a quarter wave more, let's say this is where this antenna was. A quarter wave later, this antenna is getting a 0 volt, so it starts off with negative and then gets a 0. And meanwhile, oh shoot.
That's why I used tape measure.
Right.
I broke it. So where was I? This wave peaked at minus, say 1 volt. Now the wave passed through here, and now this minus peak is hitting this one. So now this one is minus. See, this peak went minus a volt, and then it hits this antenna, minus a volt. If it hit 100 antennas, it would just keep going minus, 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 see? But I've got a quarter wave physical delay between here and here, plus another half wave section here. So what I end up doing is when this antenna over here is peaking on the, the real minus of the wave right there, this antenna, because of the phase delay and the difference here, this antenna is peaking on the plus. So look what happens. So this wave's shooting by, minus, plus, and it hits this first, minus, and then it hits this one, minus. And then this plus comes along and hits this one and goes, eh. So the two signals travel down the coaxes, and since this is delayed by a half wave, and the physical distance is a quarter wave, the two waves from antenna A and antenna B is out of phase with A, and you get the net result zero. But only in one time. It's when the beam, when this beam is facing the transmitter. It's when this longer wire, here that's looped around, when this longer wire, this is how it really is. When this longer wire is looped around and the waves are coming at you, the juice on this will exactly cancel the juice on this, and you'll lose your signal on your radio. You lose it, you totally lose it. It'll just go down in the toilet to noise. So what you'll be doing, can you hold this ball? So this is the way I'm looking, like that way. Okay. So let's do another example. Let's say the waves are coming from that door and they hit both antennas at the same time. So now you're going to get signal, because even if A is plus and B is 0, you're still going to get A signal coming through. It's going to be half voltage, but you're still going to hear it. Now B is plus because the antenna's broadside this way. So now the wave's hitting him like this. So B is plus and A is minus. B is going to overcome A, and you're still going to get a half signal, a good signal. And if you turn it the wrong way, so that's still the transmitter, now the two signals are going to hit in phase. The signal's going to come in over here and hit plus on B, have a little delay here. It's going to hit plus on A, but I should redraw the sine wave.
It's gonna be really loud.
Yeah, it's going to double your signal. When this orange wave goes floating by here, like, it's going to go plus plus. So while that one's plus, here, this is the actual signal here. But since I've got that half wave delay line plus the quarter wave, it ends up being quarter plus a half wave up here. So I get that crest and that crest when you turn the stick this direction from that door. So this will knock your speaker out because it's doubling the voltage. It's two antennas phased in phase through this harness. But when you do this, it's two antennas exactly out of phase, and you get static on your radio. And it's really, and the static is one of the sharpest you can get. It's sharper than a Yagi. This notch almost goes to 0 dB from the whole outside, which is plus 30. It almost goes down 30 dB notch compared to a Yagi in the same position. The Yagi would still be receiving minus 20. So if you really are trying to get a strong signal and notch it out, if you do the math and phase these right, and this is exactly a quarter wave, and these are electrically a quarter wave. So when the signal comes blowing by here,
No, quarter wave and half wave.
yeah, the coax is a half and a quarter, plus this half wave distance here. it adds a quarter wave to the equation. So anyhow, that's cruising around, and you're getting shh. Now I don't know if I can do it in here. I'd need somebody to like key up outside or something. But you'd be listen to this, and when you come to the what, are you going to key up?
Yeah.
What frequency are you going to be on?
147.51.
I've got
Take the side door, it's faster.
It's open too.
That'd help to be on the same frequency.
well, I don't have that on this radio, and I don't want to spend time programming it. But the test I did, thank you for offering. The test, if you turn this around all over the place and you still can't get the noise to go away, I mean the signal to go away, like you get it all the way around, then you're getting too much signal, so then this inline attenuator here, this is a 0 to minus 120 step attenuator. So the circuit is actually, from this point, the antenna point comes over here. It goes into the step attenuator, which I'll just draw step attenuator, 0 to minus 120. And then it goes into the HT right here. So that step attenuator gets you on the S meter scale so that you're not pinned. So you bring it in. And that's one thing a circuit Bob's making too, is a different kind of attenuator. I'd like to see that too. So you tune this up and down. You adjust it for noise. You get closer and closer to the signal. You keep adjusting this down until you get an on-scale reading. And you keep notching it towards this null. That's why I put these stickers on there, because this thing looks identical each way, but it's wired different. So I actually did an experiment. I keyed up our machine, our repeater, on 1/2 watt, and I went like this. I just went like this, keyed it up 1/2 watt, and I went like this. And when I got, and the mountain was that way. And when I went like this, it dropped out. When I went over here, it keyed up the machine. When I went over here, the null dropped out. When I went over here, I picked up the machine again. I keyed it up. So all the way around, it was keeping the machine up because these antennas were working in some kind of additive phase. But at that one null, it's subtractive, destructive, and it clobbered it and stopped. So I know it's working, I know it's tuned, and that's going to be my entry to the field day DF contest on this piece of fence post that I just took. The radio and attenuator. And all this is 12 gauge wire that I took the insulation off. These are electrical terminal strips. And I can do all kinds of mods to this to make it better, like put porcelain insulators here, make sliding things here to phase the antenna perfectly, make a better handle to hold it so I don't get slivers. Use stainless steel rods, but this is just a test, and it's successful because it actually has a deep null when I try it. And so that's about a 20-year-old radio on the bottom of it. So that's my talk on my antennas. Does anyone have any questions before I turn it over to the other people with antennas?
Question.
Hey,
Does that actually help you find a hidden radio better than the Yagi?
it notches it out. It gives me a tighter compass angle. So I was trying to explain that the cardioid pattern is such a deep notch. And when you, that's another option I was going to put on this is buy a Boy Scout compass from Big Five and put it on this. So when my boom, this is my boom here, this is my wood fantastic boom. When my boom is exactly lined up with where it's looking right where the transmitter is right there. And yes, I think it gives me a better notch than a Yagi because the Yagi pattern is
Right.
wide. But it'll get you there. It will get you there. The Yagi pattern has this uncertainty. Its lobe is out like this. Something like that. So if you're getting a signal between here and here, you got some uncertainty of what angle to aim your compass. So you got to be good at getting your angle right. But both of them, all three types work, and there's probably more types than this. I've seen more in books and stuff, but that antenna there you can use to transmit on. Mine, if you drove around with this crazy thing, you'd be out of the repeater when you're turned towards the null, and you'd be into the repeater when you were on this side of the antenna. So this one's no good for talking, but it's good for finding the noisy spot.
Which is what we're looking at trying to do with this fox hunt that we'll still be talking about figuring out what we're going to do there, but we're probably not going to worry so much about actually building antennas, but making use of some of these antennas that Bruce and Kevin have put together, and just going out and seeing it work is what we all like, I think, to do. So we'll be dialing that in more.
And this one's a J-pole, but it's just omnidirectional. Everyone knows what that means. If you look straight down on the antenna, and you saw how powerful it was, it's got like a perfect circle. So no matter, it transmits in all directions equally.
Equally inefficient in all directions.
Yeah.
And by the way, on J-poles, they only transmit not from the base, because this is a matching section, these two wires. They don't start, this matching section cancels out this one, exactly how this works. From my thumb up is actually the active antenna. All this other crud down here is just matching. This stuff doesn't radiate. The J part doesn't radiate. It's from my thumb up. There's two quarter waves here. Here's a quarter wave. Here's another quarter wave. So it has gain over a single quarter wave, like this. So that's omni. These are directional. And now, who wants to go next? I'm kind of looking at you, Bob. Do you want to go next?
Got about 15 minutes.
Okay, yeah, it won't take long, because I'm a small brain radio guy.
There you go.
So there's this fox hunting stuff is a sport. And there's people running around parks every weekend with these antennas, with these tape measures, looking for radio finders. So when Kevin started talking about it and I got online, you see all kinds of references to these tape measure Yagis.
Yeah.
So I said, what the heck, I'm going to build one. So because I got lots of broken tape measures. So there's a guy, WB2HOL, he's, this is the plan that I followed. This is really nice. You can cut your pieces. They give you the dimensions. You can just read it right on your tape measure, take your snips and go.
Yeah.
So it's really easy to build. So the interesting thing though, and Bruce was talking about the patterns, when they built this design and they ran it on the scope, it has a notch in the back. Probably not as much as that. But it's got
Classic ones have that.
Yeah, I think the classic Yagi you definitely would get a signal in the back. So I think the interesting thing on here is that you're basically soldering your coax to your drivers, and it's got this hairpin match. And you get your 50 ohm impedance by spreading these two apart. So So I actually tuned it for like 146.2, but it's pretty flat across the 2 meter band. It works great as a receiver, and it's got polarities. I mean, you can do it this way, you can do it sideways, but I mean, it's actually got pretty good gain as a transmitting antenna, even a receiving antenna. But that's a kind of a problem, because when you get close to the source, then it's like too strong a signal. You know, so you'll be looking, and if you're far away, that's great. And you just hook it up to your radio, you know, so you have a little jumper, and you can look at your estimator. So there's this other guy who's really into this chasing, and it's AC9ON, a little outfit called Third Planet Solar, and he puts out a kit. It's a offset attenuator. So again, it's the same thing. The signal's too strong. When you get close, you've got to attenuate the signal. So what this gizmo does, you get a little bag of parts. He sends you all these little parts in a little bag like this. You get a circuit board, a whole bunch of capacitors, one diode, a transistor, all this stuff. I had no idea what it was. With great instructions. I mean, you know, I wouldn't have been able to figure this out. But it's got a nice printed board. You just match up all the parts, solder them on. And what it does is adds 4 megahertz to both sides of the signal. It takes away 4 megahertz, adds 4 megahertz. So if you're looking, if your signal is 146, you're going to dial your radio to 142. And then that's what you're going to search for. And it'll attenuate that signal. So it's got a little on-off switch, a little light to tell you if it's working. And then it's got a potentiometer that'll actually let you kind of custom dial the attenuator. But you're really looking for a signal that's 4 megahertz of your target signal. And so I attached it to the antenna. Now I learned not to glue anything on this yet. So,
Yeah.
I'm not sure. So when you put the attenuator on, it's not going to be a transmitting antenna. So I'm not sure I like that idea, because literally you could use this for distance. You could do those moon bounce things that Marcus is always talking about.
Hit satellites and
You
stuff.
can
with
talk
these.
Space station.
Space station, not with this.
No.
No, you might with satellite, yeah.
Maybe satellite.
Yeah.
So, but I think when you put the attenuator on, it's not, then you can't transmit it. So, sure.
Are we stuck to one frequency on that?
No, it'll. Well, I tuned it for the 2 meter band for our range, but I mean it's pretty broad band. I mean, Bruce had a great idea in terms of how to test it, and I was testing it on KUIC, which turned out to be too strong a signal before I got the attenuator. I was doing the weather today out in the rain. I was doing the weather signal out of Sacramento, and it had a really good directionality to it. So
Phone's gotta be close because you're not transmitting on it.
yeah, so
162 megahertz.
162.55.
Okay.
Yeah. So that's my little antenna project, and it's great because the only thing I had to buy really were these crosses, which I didn't have in my inventory of parts, and I didn't have enough hose clamps, so I bought some hose clamps.
What's the total investment?
Oh, for this part of it, probably the hose clamps were the most. I'd say maybe $10 maybe total. I had a broken tape measure, so that was pretty easy. Now from here down, the offset attenuator, $8
$8.
plus $3 shipping.
So you're into the whole thing, $20.
Yeah, maybe.
For your offset attenuator, what was the call for
It's Third Planet Solar is the guy's website.
third
So,
plant?
Third Planet.
Oh, third planet.
Like third rock from the sun. Third rock from the sun. Yeah. Third Planet Solar, and he's really into fox hunting.
Wasn't that antenna in QST a couple months ago?
I didn't see it. It's been in QST before, and there's a lot of different versions. And I just happened to use the one that this guy had put together because he had a really nice set of directions that I could print out.
It always helps, doesn't it?
Yeah, jeez. So it's really easy to build. So that was my little entry into the. And the nice thing, you hear people say they can crash the brush. People run around. Kids can use this thing. You
Good
drop
idea.
it, and if you break it, then you just put another section of tape measure on. It's not that big a deal.
Have you actually fox hunted with that at all?
No, in fact, I just finished this today.
Because I was wondering, You know, when you're a distance away, you'd run it vertical, because more than likely the transmitter on that's hidden has a vertical antenna.
Yeah.
Then, so you've got a strong signal. As you get closer, rotate it over to horizontal to get a lesser signal as you get closer.
Yeah, you can definitely, you can mess with the orientation, you know, the polarity.
Right there.
Mess with the attenuator.
How hard is that circuit? Oh, it's only like a postage stamp, small.
It's about the size of a address label. It's got a whole bunch of parts. It's like,
Where'd you get yours anyway, Bruce?
Mine on this was just swap meets.
Yes, I thought.
It's an old HP, they don't make them anymore.
Yeah, but those are kind of expensive.
Well, they were new.
Yeah, I use those at work.
$10 now, I don't know.
this one was fun because I'm not very good at soldering. And it was a great practice. And I was really glad to do it without melting the boards, which I or like mushing them all together. So when I flipped this, when I flipped the switch and the light came on, I was like, yes.
Plus you got a signal when you're reading too.
Yeah, no, yeah.
That was really cool.
Good job, Bob.
Yeah. Is there anything else? We got about 5 minutes.
Everybody knows what body bait hunting is? This is when you're close,
Give us a recap.
you know, and you stand this way and it's stronger, and you turn your back on it and it's weaker, then you know it's in that direction. And this is for fairly close in stuff. And when you get really close, rather than, and I saw Kevin had a nice little slide for an attenuator.
Trombone.
I thought I'd show you my attenuator. So,
It's got metal
well, you need a
inside.
string, but if I put the antenna inside, this is a cardboard tube that's wrapped with aluminum foil.
That's a good idea too.
And I was on one of these, the guys down in Benicia have hide it out in the parking lot, and I was really, really close. You know, and everybody else was around there. And so I dropped it into the tube, and of course it's getting weaker and weaker and weaker. And I couldn't find it. And as I dropped it all the way into the tube, it started getting stronger again. What does that tell me? It tells me that I was about stepping on it. It was right underneath, and I was getting closer to it. So anyway, it's just a real cheap attenuator for the close in.
That's a good one too. How about the owner of this nice antenna here? Who uses that? Let's talk about that one.
I built this one from, it's basically the same thing as he's got, but one thing I learned from my gold mining days was you build everything a little bit tougher to handle the terrain. So I added these here. They can take it off. If I wanted a lighter handle on this thing, they'll come off. I also plan, I haven't put in the loop here that goes in here yet, but I plan also to put a piece of plastic here that I can mount the meter on. And then got one of my old compasses, a plastic compass, and I'll put that on there. And it's got a flip up and got the lines so you can read from it. So I don't know how much it'll interfere with being able to receive with the stuff, but that's where I'm going with this.
It'll look cool, that's for
Is this
sure.
when you break out your old Boy Scout stuff?
Yeah.
There you go.
Nice.
So, yeah, right there.
Well, that was good.
Excellent.
All right, anything else?
Kevin wanted me to mention that Kevin actually brought up this T-Hunt, and I took some notes. I talked to him today. He said he'd like to talk to us again in March or sooner. Maybe sooner means not at a club meeting, but maybe even somewhere else. But he's gung-ho to speak of all the stuff he knows, and he knows a lot about fox hunting. When will the fox hunt be? He says that's up to the club. April, when the weather gets better, or later.
Okay.
Where is the fox hunt going to be? How big of an area? And he says it could be as small as a park or 5 to 10 square miles. It depends what we decide. How long does it take to do a fox hunt? He said about 2 hours plus to find it, usually. Are we going to get a list of supplies? He said yes. He's going to get to us where to buy the map, the acrylic pad, the grease pencil, protractor, compass with a ring, how to make the attenuator, and you saw today how to make different antennas. And where to buy all this stuff? Big Five, Walmart, Office Depot, such and such like that. The rest of it's hardware store items.